All right, let's talk about something we see, touch, and use every single day, but probably never ever think about. It's literally the foundation of our modern world, but it's so common that it's basically invisible. So just think for a second, what's the one material that makes everything from your morning commute to global shipping even possible? The thing that you rely on constantly, but probably know almost nothing about? Yep, you're driving on it. We are talking about asphalt, the blacktop, the pavement. And in this explainer, we're going to dig in and uncover its surprisingly fascinating story, from deep geological history all the way to some really cutting-edge science. Okay, so first things first, what even is this black stuff we call asphalt? Well, the answer is a little more complicated than you'd think, and it all starts with getting two very important terms straight. So here's the key distinction you gotta get. On one side, you have the asphalt binder. Think of this as the super sticky black liquid glue. Its technical name is bitumen. Then, on the other side, you have asphalt concrete. Now that's the final product, the stuff you actually drive on. It's a mix of that sticky binder plus a whole bunch of rocks, sand, and gravel, what we call aggregates. Now get ready for this, because this part kind of blows my mind. You'd think a road is mostly that black gooey stuff, right? Wrong. Take a look at this. A road is actually 95% rock and sand. Only that tiny little 5% is the asphalt binder, the glue that's holding all that stone together. It's amazing. Our entire transportation system is basically riding on a skeleton of rocks. So where does this magical black glue even come from? Well, its story is millions of years old, but at the same time, it's as modern as the fuel in your car. It has this really cool dual origin. Okay, so picture this. Millions of years ago, tiny little sea creatures die, sink to the ocean floor, get buried, and then cooked by the Earth's heat and pressure. This is what forms crude oil. Well, sometimes the lighter parts of that oil seep away, leaving behind these super thick, natural pools of bitumen. Think of the La Brea tar pits. Ancient civilizations found this stuff and used it to waterproof their boats and buildings. But it was the car in the 20th century that created this absolutely massive demand for smooth roads, and that leads us to where we get most of it today. And that place is an oil refinery. See, when you take crude oil and cook it to separate out all the valuable fuels like gasoline, diesel, and jet fuel, the asphalt binder is literally what's left at the bottom of the barrel. It is the heaviest, thickest, gooeyest stuff that doesn't boil off, a byproduct that just happens to be the perfect ingredient for paving our world. But you can't just take those leftovers and slap them on the ground. No way. Making a modern road is a serious science. It's like baking a cake, but it's a super precise recipe that has to withstand weather and thousands of pounds of pressure. And it all hinges on one really cool property. And that property is called viscoelasticity. elasticity. It's a great word, right? All it means is that asphalt is a bit of a shapeshifter. It acts like a solid sometimes, but at other times it acts like a really thick liquid. Think about honey or even silly putty. This is exactly why a road gets a little softer and can rut in the summer heat, but then it gets hard and brittle and can crack in the freezing cold of winter. Engineers have to nail this property perfectly. And that's why no two roads are ever exactly the same. Engineers cook up a unique recipe for every single project. They have to think about everything. The local climate, is it hot like Arizona or freezing like Alaska? How many heavy trucks are going to be driving on it? How long does the road need to last? Does it need to drain water? They even have to consider the specific shape of the little rocks they use. It's an incredibly complex balancing act. The whole process is basically a four-step dance of heat and pressure. First, the recipe is perfected in a lab. Then, at a huge plant, all those rocks get heated up to incredibly high temperatures and coated with the hot liquid binder. Next, a paving machine comes along and lays down that steaming hot mix in a perfectly smooth layer. And finally, these giant, heavy rollers come and compact it all down, squeezing out every last air pocket to create that dense, strong surface we drive on. So we've been talking a lot about roads, obviously, but that is just the beginning of asphalt's story. Its unique properties, especially that it's sticky and totally waterproof, make it one of the most versatile building materials we have. For starters, look up. There's a good chance the roof over your head is protected by asphalt shingles. They're just layers of that binder and some fiberglass, making a perfect waterproof shield. How about airport runways? These things need super specialized heavy-duty asphalt mixes to handle the insane weight and stress of a 747 landing on them. It's way tougher than your average neighborhood street. And then you've got performance and safety.
High-speed racetracks use custom asphalt recipes for incredible grip, while playgrounds and bike paths use it to create smooth, safe surfaces to play on.
And finally, we come full circle, back to its ancient purpose, waterproofing. It's still the master at sealing basements, tunnels, and coating pipes to protect them from rusting away.
Okay, so I know what you're thinking. It's a petroleum product, right? That doesn't exactly scream eco-friendly, but the last and maybe the most surprising part of this whole story is asphalt's role in sustainability. Take a look at this. Number 1. What in the world do you think this represents? I'll tell you what, it's something incredibly positive. Get this. Asphalt pavement is the single most recycled material in many countries around the world, by a long shot. Old roads aren't just dumped in a landfill. Nope, they're milled up, crushed, and that old material, both the rocks and that valuable binder, gets mixed right back into new pavement. This dramatically reduces the need for new oil and new rocks. And the innovation just keeps going. Engineers have developed warm mix asphalt that uses way less energy to produce. There's porous pavement that lets rainwater drain right through it, which helps reduce sledding. They're even adding things like recycled tires and plastics to the mix to make roads last longer. And scientists are even looking at making binders from plants and waste oil. So this ancient, seemingly boring black stuff is constantly being reinvented, which really makes you wonder, right? With all these new technologies on the horizon, what if the roads of tomorrow could do more than just get us from A to B? What if they could actually clean the air, cool our cities, or even wirelessly charge our cars as we drive? It's a lot to think about the next time you're just driving down the road.